I'm Anil Kumar, and in this video we are going to understand how to write equation of a polynomial from the given graph and describe its characteristics. The question here is, write a polynomial function from the given graph and describe its characteristics. So we have graph of a polynomial, opposite ends, as you can see here. It means odd degree function. To write the equation of this graph, we should look into the zeros or the x-intercepts. So it has 1, 2, 3, 4, 5 x-intercepts, and all these x-intercepts we see that the graph crosses like a straight line. So they are all with multiplicity of 1, right? So these we say are zeros with multiplicity or order as 1. From here we can write down the equation in factored form. So let me write this as f of x equals to a times, first 0 is x plus 3. I mean 0 at minus 3, so the factor will be x plus 3. Then this 0 is at minus 2, the factor will be x plus 2. Then we have 0 at x, 0 at x plus 2, which means factor is x minus 2, and here the factor is x minus 3. That is going to give you 0 at 3. Now that becomes kind of equation. We need to find a, which we can find using the point p, which is given to us as 1, 12. That means f of 1 is, substitute 1 for x, so we get a times 1 plus 3 times 1 plus 2 times 1 times 1 minus 2 times 1 minus 3, and this should be equal to 12. The value at what is 12, correct? So that helps you get the value of a. Now 1 plus 3 is 4. 4 times, let's rewrite this. So we have 12 equals to a times, so what we have here is 4, 1 plus 2 is 3, times 1 times 1 minus 2 is minus 1, and 1 minus a is minus 2. So that is equal to, minus and minus makes it plus, right? And then we have 2 times 3, 6 times 4 as 24, right? So 4 times 3, 12, 12 times 2 as 24. So we could write this as 24a, and that gives you a value of a as 12 divided by 24. So we say a is equals to 12 divided by 24, or half. Correct. So we know that a is half for us. So that gives us the equation. So let me rewrite the equation on this side. So we have the function f of x as equal to a is half. And we'll rearrange these factors. It's good to write x first. And then we'll write all other factors. X plus 3 times x plus 2 times x minus 2 times x minus 3, right? So that becomes the equation for the given graph, right? I hope you understand the method. So method is using the zeros, write down the possible equation, find a with the help of the given point. Now let us concentrate on characteristics. So characteristics, what do you notice? 1, since the end behavior is opposite ends, right? So it is, we can write end behavior. And that is when x approaches minus infinity, this side, y approaches minus infinity, and when x approaches positive infinity, y approaches positive infinity. That is one thing which you see. And then you also notice that the polynomial has degree of 1, 2, 3, 4, 5. So it is odd degree polynomial where degree is equals to 5. We could write degree from this particular equation also. Now, since the right side is up, we know leading coefficient is positive, right? We know leading coefficient is positive, right? So we can write leading coefficient is positive. Now, I have purposely given you these three to begin with because from the graph itself, you can check that the end behavior or degree, since it is opposite ends, and right side up means leading coefficient positive. So this is the reading from the graph itself. Now we can count the turning points. So turning points are 1, 2, 3, 4. So we have 4 turning points. And we also know zeros. We know there are 5 zeros. All are linear. And they are at x equals 2, minus 3, minus 2, 0, 2, and 3. What else do you notice? A very important thing which you notice here is this function is symmetric about the origin, right? So it is symmetric about origin. That really means that this is odd function. When we say odd function, it means f of minus x is equals to minus of fx, right? So this is a very important conclusion from this particular graph. You'll see all these zeros are symmetric about origin. They're same distance away. Even if I draw a line from here to there, this point is going to be symmetric here, and this point will be minus 1, minus 12. So this graph is symmetric about origin, and therefore we say this polynomial is an odd function. It has odd symmetry. We should say, or you could say it has odd symmetry. Symmetric about origin is odd symmetry, right? Now, domain and range is always a good characteristics to remember and write. Domain for any polynomial is x belongs to real numbers, and since this is odd, range here is y belongs to real numbers, right? So domain and range, x and y belongs to real numbers. So these are the characteristics which you could write about the given polynomial. I hope that helps. So it is important to note how we can get equation, and all this information we can actually read from the graph itself. Thank you and all the best.